Okay, pre-calc, we're still in 4.1. I'm going to go over more topics. So the next thing I want to talk about is something called coterminal angles. And I underlined this in my book because this is really important. This is page 262. Two angles are coterminal when they have the same initial and terminal sides. So what that means in basic terms is that they start and they stop in the same spot. They start and they stop in the same spot, okay? So let's try this so we can see if we get it. So let's say I have 45 degrees and I want to find a positive coterminal angle and a negative coterminal angle. I may occasionally write angel. I usually get it right, but if here and there you see an angel on my paper, you know I have my L and E swapped. Okay, so the idea is let's look at 45 degrees. Now I'm just going to give you a generic rule, but you got to watch, because if something falls out of this generic rule, you have to slightly modify. All right, here's 45 degrees. So this is always, for rotational trig, this positive side of the x-axis is always the initial side. And again, where you stop is called the terminal side. So to make a coterminal angle, you have to start and stop. Any angle that starts and stops at these spots is considered a coterminal angle of 45 degrees. So the idea is if I go all the way around the circle, I can come back to this spot. And if I go all the way around the circle is 360 degrees, okay? If you want to get back to the same spot, you have to go 360 degrees. So the idea is for a positive coterminal angle, if I take 45 degrees and I add 360 degrees, I'm going to get 405 degrees. And that is indeed a coterminal angle. There are an infinite amount of positive and negative coterminal angles, because you could just keep going. It's like a merry-go-round. I could just keep going. I could lap twice and stop, or I could lap 3 times and stop. You could go on to infinity doing this. So let me just draw this for you so you can see it. So I did the positive coterminal angle. So 405 degrees, that would mean that I start here, I travel 360 degrees. I'm writing it as a snail shell so you can see it. And then I go another 45. Okay, I'm just writing it as a snail shell so you can see it. So I went 360 degrees and another 45. And if you notice, in both the graphs, the initial and terminal sides are the same, so they're indeed coterminal. Now I could go around the circle again, another 360 degrees, and that would also be coterminal. So again, you could just keep wrapping and wrapping and wrapping all day long. So in general, to make a positive coterminal angle, you add 360. Okay, in general. If you're starting with an angle like negative 750, you're going to have to add a couple plus 360s before it becomes positive. So you may have to add 360 more than once until something is positive. This works in general, as a general rule, okay? Then you can probably guess for a negative coterminal angle, you would start. So for negative, you have to go clockwise. Negative angles are clockwise on rotational trig. So a negative angle, coterminal angle, you're just going to wrap around it in the opposite direction, okay? You're going to wrap around. You want to get back to the terminal side, but going the opposite way. So what you're going to do for that is, instead of adding 360, you're going to subtract 360. And make sure your answer is negative. And again, this is just a standard rule. If you're starting with an angle that's like 900, you're going to have to go more than 1 minus 360 before it starts going negative, okay? So this is just the general idea. Let me draw this one for you. So negative 315 starts here like all the angles do in rotational trig, but it rotates this way to get to the angle. It rotates clockwise. So negative is clockwise, positive is counterclockwise. Now I'm going to ask you, if the question starts in degrees, stay in degrees. If the answer starts in radians, stay in radians. Okay, so let me show you what I mean by that. I could have started, let me just sort of, I don't have to like super explain a lot. Make this video like 20 minutes long. I could have said, instead of 45 degrees, I could have said pi over 4, and then you would have had to stay in radians. So in radians, you would be adding 2 pi, okay? Because that's the same thing as adding 360. 2 pi is a full rotation around. But these are fractions, so you're going to have to get an LCD, right? I have to multiply up down by 4 here. So this is the same thing as saying pi over 4 plus 8 pi over 4, which is going to end up being 9 pi over 4. So if the original question was pi over 4, your final answer would have been 9 pi over 4. So if it starts in radians, you want to finish it in radians. If it starts in degrees, you want to finish it in degrees. Likewise, on this one, you would start with pi over 4. You would subtract 2 pi, right? You want to stay in radians. So I'm going to do pi over 4 minus, right? You've got to get an LCD, so you multiply up down by 4. So it's negative 8 pi over 4. So 1 minus 8 is negative 7 pi over 4. So this is the final answer. Let me maybe circle these. So this is the final answer in radians. It's these are equivalent values. They're just in different units, right? This is in degrees, this is in radians. That's like giving the measure of something in feet versus yards. You can just represent the value in different units. So that's what I'm doing. I'm representing the degrees in different units. Okay, so just to reiterate, a coterminal angle. A coterminal angle is when they have the same initial and terminal side, so the same start and finish. All right, this video is already at 8 minutes, so I'm just going to leave it here because coterminal angles is an important concept. We're going to revisit it again in chapter 5, so you will be seeing a lot of this guy. You want to know how to find these. Okay, I'll pick up in the next video then. Bye-bye.